Multiplication of exponents. Okay, if you remember, we have a base, which in this case is a 3, and a power. Okay, as long as the bases match, you can put them together. So in this case, it would be 3 as our base. And then what you do is you add your bases together, or your powers together. So it becomes 3 plus 4, which is 3 to the 6th power. Then you can figure it out to be that that is 729. Okay, let's try another. We can do 2 to the 5th power and 2 to the negative 4th power. Since the bases match, we can write down the base and then do 2 plus a negative 4, which would be 2 to the 1st power, or just 2. Okay, like I said, you cannot put them together if they're not the same base. So if you get a problem that is like this, that it's 3 squared times 2 squared, you can't put them together. You'd have to figure out that this is 9 times 4, which is 36. This only works if the bases are the same. Okay, and just like the same, if you have just variables, you can do the same thing. So in this case, Q is our base, so Q. Then it becomes a negative 6 plus a negative 1, which becomes Q to the negative 7. And if you remember from our last lesson, we cannot have this, so these are all going to move to the bottom, so it becomes 1 Q to the 7th power. Okay. You can also run into times where you're going to have 3 of them, so we have 3 2 bases, so write down your 2, and then it becomes 3 plus 5 plus 1, which in this case is 8, 9, so 2 to the 9th power, which is 512. Okay. Now, when you have ones that are mixed with constants and variables, you take your constants, which is 2 and 3, and you multiply them. Then do your variables, which in this case, even though it doesn't have it, there is a 1 up here. So then it becomes 1 plus 2. So that becomes x to the 3rd power. And multiply your 2 times your 3, which would be 6. So this would be your answer for this one. Okay. There'll be times when you get multiple ones. So once again, multiply your constants, which would be 3 times 5, which is 15. Do your variables, which is x squared plus the 4. And then you have your y, the negative 3 plus a negative 2. So 15, x to the 6th power, y to the negative 5. And like we did in the last lesson, these ones are going to have to move down. So it'll be 15, x to the 6th over y to the 5th. Remember, they become positive. Okay. Now we've worked on distributive property. You can have the same thing. This is going to distribute in. Now here's what changes when you do distributive. And then it becomes h, and then it becomes times. So you do 2 times 5 in this case. And that only happens if you distribute. Having the parentheses let you know that. So then you have h to the 10th power. Okay. So you would do the same thing here. Distribute the negative 2 in. So you get q, so that becomes 4 times the negative 2, which is the negative 8, which once again we know we got to move to the bottom. So it becomes 1 over q to the negative 8. Okay. Now when you run into ones like this, it's going to distribute to both. So this becomes 3 to the 4th power and b to the 4th power. Okay, so this becomes 81, and this becomes b to the 4th power. Okay, once again, distribute, so it becomes negative 5, and that's going to hold in there, squared, and then k squared. So this becomes positive 25 k squared. you will run into some where you've got to do it on both sides. Okay, this is an S. Okay, so distribute to this one, distribute to this one. So this becomes S 4 times 3, which would be S to the 12th power. Distribute that, so it becomes times X to the 3rd. Keep it. Times, and then on this side, distribute your 2 in, so that becomes S 4 times 2. So S to the 8th power. Distribute in here, and that's 3, so this is X 3 times 2, which is 6, so times X to the 6th. Okay, so now combine what you can. So this would be S 2 plus 8, so S to the 10th, times, this is X 3 plus 6, so it's X to the 9th power. And since there's no more you can do, this is where you would stop. Okay, let's take a look at one more. Okay, in this case, with this one, we're going to distribute this 3 to everything. So to the 2, to the m to the 0 power, to the n to the 1st power. So let's go ahead and do that. So 2 to the 3rd power, m, and it's 0 times 3, which is 0, and then n to the negative 1st power, so it's negative 3, times, and square it, n square into the cubed, m to the negative 12, and then n to the positive 12. Okay, so first, let's combine our like terms. With our constants, we have a 2 and a 2, so it's going to be the base is 2. Combine our 3's, which is adding in this case, to the 6th power. Combine our m's, so 0 minus 12, so it's m to the negative 12 power. And then our n's is, it's going to be n negative 3 plus 12, which would make it a 9, so n to the 9th power. These ones can't be up there, so we're going to move them to the bottom. So it becomes 2 to the 6th power, n to the 9th power, and then the m's are on the bottom. Okay, and then 2 to the 6th power for finalizing the simplifying is 64. So 64n to the 9th power and m to the 12th power.